Hi guys, good evening to all. Are you there, everyone? Okay. So today we will start sequence and series, right? We have finished permutation and combinations. Hope you have tried exercise, all the exercises of your book, hopefully. I'm not sure. I'll share the screen and you let me know if you are able to see it. Okay. Okay. Are you able to see the screen? Can you see the screen?
Yes, sir.
Okay. So what happened to Murli? Why is not coming to class? Is sick or what? Hari? Hari Raghav?
Sir, I think last class he came from
He was
chemistry.
there?
I think he will join late.
Okay. Okay, fine. Okay, so we will start with sequence and series. Hmm. Let's wait for others to join. Okay, just give it a second. This chapter is finished in your school, hopefully. Huh? Anyone?
Sir, it's going, sir, not finished.
Okay. So what do you mean by sequence and what do you mean by series? What's the definition? English definition. I don't want any mathematical definition. Sequence. What do you understand from sequence?
Order of numbers, sir.
Order of numbers. That sequence means order, right? Order of number, or it can be anything, object. Let's say object. And series, what do you mean by series? Anyone? Series, it is composed of total number of objects or events, right? So let me write number of events. So number of events in order, events or object, whatever you feel is right. So whatever, let's say you have something in number, like you have a red pen, a blue pen, a black pen. Okay, so these three pens you have, red, blue, and let's say what, green. Let's say green. So what order you arrange, so that is your sequence. And how many are there? There are three, right? So that is your series. So it is a series of three. Understood? Series of three. Got it? Understood? Was that means number of events or object in a particular order we are going to study that that is what sequence and series is all about. So in sequence and series, we are going to learn about, first one is arithmetic progression or arithmetic series, we can say. Then arithmetic mean, geometric progression or geometric series, geometric mean. And we'll also see some of the examples of harmonic series, harmonic progression, that's right. Okay, and up in this itself, we'll see, we'll talk about exponential and logarithmic series. Okay, exponential and logarithmic series we will talk about. Will that be okay? So can you tell me why are we even studying sequence and series? What's the use of series? Can you tell me any series? that exist in real life. Any sequence and series that exist in real life. Let's write down real life example. In paper, theoretically, so we can have a lot of examples, right? Tell me one smallest or one example that you see in your everyday life. Yeah, Nidhi, use your head. You all know this. You all know the answer. Yes, sir. Hari, I can see you. Okay. Abhinav, Shrikruti, where is your friend? The second biology. Trivya, right? Trivya.
Sir, she's not feeling well.
Okay. Tell me a real life example of sequence and series that you see in your everyday life. It's good that we are having online class, right? Already started raining. Okay. Okay. Yes, madam. Anyone? Nidhi, Hari, Hari Raghav, Naveen, Abhinav. Natural numbers, yeah. Natural numbers. Thinking how much you have to think. Natural number example you see all the time, right? People around you, class of people, like the number of people in this video call. Those are all natural numbers, right? All are natural number, isn't it? So natural number is one real life example. What else? This was a little bit of mathematical number, but anything apart from this, what can you tell me about this? A real life example of sequence and series. Have you heard about Fibonacci series? Huh? Yes or no? How many of you have heard about Fibonacci series? Huh? What is Fibonacci series? Fibonacci series. Or Fibonacci series or Fibonacci sequence also you can say, it's fine. The series is just numbers. Okay, how many number and in a particular order. So Fibonacci series, what is Fibonacci series? Where from it start? It start from 1, right? 1, 1, and all the next number will be the sum of the previous two numbers. So 1 plus 1 is 2. Now 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8, and like that, so on. This is your 13, and so on. So that is your Fibonacci series. You can see the real life example of Fibonacci series in the order. The petals will grow in a flower. Okay, so the growth of petals, or let's write flower. I just write flower. Okay, or the spiral of a seashell. Right. So these are some of the real life example of, okay, so growth of this flower. These are some of the real life example of your sequence and series, right? What else? Like growth of bacteria. Growth of bacteria. Or growth of population. Population growth in general. Population growth of any population, means like of a city or of a particular town, of a country, whatever. So these all comes under exponential series. This is example of exponential series, right? What else can we give example of? Do you know the example of any other example of exponential series or logarithmic series? Like, how do we measure earthquake? Earthquake. How do we measure it? What's the equation of magnitude of, what is the Richter scale we use it, right? So that is m is equal to log 10. The base we are taking 10, k to the power of 0.7 upon 10 to the power of 0.9, something like this, where k is your amount of energy released. Okay, k is the energy. what else? This is the Richter scale. That's how we measure it. Or it is also sometimes expressed in like a log k minus b. Okay, and a and b is a constant. A and b are constant. Have you studied the chapter of sound in physics? Huh? In 9th standard, though, you must have studied sound, intensity of sound. How do we measure it? In decibels, we measure, right? So intensity of sound, how do we write it? L, let's write L is equal to log. Usually we write log 10. Okay, let's be log I upon I naught. This decimal, log 10 log 10. 10 log 10 I upon I naught. This is measured in decibel. The intensity unit is decibel. I is the intensity of sound and I naught is some reference sound intensity. Okay, with reference to something, we are measuring the sound. So these all comes under logarithmic series and exponential series. How do we measure it? Or sometimes, have you heard a fighter craft or airplane going from you, by your side, somewhere nearby? So it will release a wave, okay, in form of this concentric circles like that, sound waves. Okay, so these are also in the magnitude. This is also your exponential series or logarithmic series. Like you have studied the function sin x, right? Sin x you have studied, no? Have you studied this or not? Please tell me yes. Somebody. Anybody is listening or everyone left?
Yes, sir.
Okay, please let me know. Otherwise, I'll just be, telling something and nobody is listening. Don't want that. Okay, sine and cos, these can also be expressed in terms of series. See, this is your trigonometric function. This can be expressed in algebraic function like 1 minus x cube upon 3 factorial. Sorry, x, not 1, it starts from x. X plus x to the power 5 upon 5 factorial plus so on. So this is your algebraic function equivalent to your sin x. So this is algebraic function, not algebraic. Okay. What else? Like exponential functions can also be expressed in that manner, but again, you are going to study that So these are some of the examples of your sequence and series, right? So these we are going to learn. Of course, we are not going to learn about this, the last example that I gave you, but you will, I hope that after this chapter, you will be able to understand sequence and series. Okay. So first we are going to study about some very, the first topic will be on arithmetic progression. That's right. Arithmetic progression. What is arithmetic progression? What do you mean by arithmetic progression? Yes, anyone? What do you mean by arithmetic? Please, somebody. Anyone?
Sir, that particular order has a common difference, sir.
Who is this?
Sham, sir.
Sham. Okay. Yeah. Tell me Sham again.
That particular order will have a common difference, sir.
Particular order have a common difference. Okay. Anyone else? What do you mean by arithmetic? You tell me just arithmetic, not progression. You just tell me about arithmetic. See, it's a theory.
Something related to numbers.
Yes, very good. Anything related to numbers or the study of numbers, we can say, the theory of numbers. Okay, good. Theory of numbers. That is your arithmetic. So in arithmetic progression, we are going to study about the how we can arrange a number in particular order. Okay, then you can say why then geometric progression is a little bit different from arithmetic order when we are studying the same thing. We will see that again in upcoming classes. Okay. Now tell me one example. Acha, tell me first about the prime numbers, series of prime numbers. Anybody? Prime numbers, series of prime number. Can anyone tell me? 2, 3, 5, 7, 11, 13, 17, 19, right? So these are your what? Prime numbers, isn't it? Yes or no?
Yes, sir.
Yes, sir.
Anything missing here? 1 is also a prime number? Yes or no?
Sir, it's
No,
neither prime
sir.
or
1 is not a prime number? Okay.
No, sir.
Okay, 1 is not a prime number, yes. So see, now again, here also you see there are numbers in a particular order, right? The number are on particular, and the order is that it is divisible by itself and 1. That's it. Okay, that is the order, and there are certain numbers. So there are some numbers which shows this property. So those are called prime numbers. Have I told you about prime number conjecture? Okay, let's leave it. It's not the topic. See, in arithmetic progression, we have, okay, so I'll write a series. You tell me what common thing that you can find here in the series. Okay, 2, 4. It's a very simple series. 6, 8, 10. What do you find common in this? Yeah, anyone
Sir,
please tell
2
me.
is common in it. 2 is common, sir.
2, that means the next number is a sum of just 2 in the previous number, right? That means yes.
Sir.
So every time if you subtract the greater number with the smaller number, so you will find the difference 2, isn't it? Right? So this is called your common difference. Common difference. And since if the common difference is constant, then we call it that these numbers are in arithmetic series or arithmetic progression. Okay, so it will have a common difference, and of course wherever it starts from, this is called the first term, isn't it? First term. Okay, and this, of course, wherever it will end, it will be your last term. So these are the definitions you are aware of, isn't it? First term, last term, common difference. Yes.
Yes, sir.
Okay, so first term is also, you can say T1. So here T1 is 2, second term T2 is 4, third term T3 is 6, fourth term 8, and the fifth term is 10. So there are a total of 5 terms here, right? So this is the easiest example of arithmetic progression that I can give you. Now tell me, since there is already a common difference D, which is equal to 2 common here in all the, if all the terms, that means if you subtract T2 from T1, T2 minus T1 is equal to T3 minus T2, that is also equal to T4 minus T3 is equal to T5 minus T4, which is equal to 2. This is called your common difference. That means you can find the difference of any 2 terms and it will remain constant throughout the series. Okay, in arithmetic progression. Okay, or arithmetic series. Okay, so let's solve some of the questions based on this. Okay, first tell me whether this is a arithmetic series or not. 1 upon 3, 1 upon 6, 1 upon 9, 1 upon 12. Is this in AP or not? Huh? Yes, Naveen, is this in AP? AP means arithmetic progression, or AS also you can say. Usually we use the term AP. Yeah, Hari, is this AP or not?
Sir, yes, sir.
This is AP, arithmetic progression.
So difference is 1 by 2.
Difference is 1 by 2. Are you sure?
Yes, sir.
Okay. Anyone else? This is a Hari Raghav, right?
Yes, sir.
Okay. How many terms are there total? T1, T2, T3, T4. Find T4 minus T3. Somebody finds T3 minus T2. Somebody find T2 minus T1. Tell me all these three. Hari, you tell me the first
T2
one.
minus T1 is
Sir, it's
minus
1 by
1
6,
by
sir. It's 1 by 6, sir, not 1 by 2.
Wait. First T2 minus T1, who said? Kruti?
Sir, Shreya sir.
Shreya. Okay, Shreya, tell me.
Minus 1 by 6.
Minus 1 by 6?
Yes, sir.
Yes?
Yes, sir.
Okay. Find T2 minus T3 minus T2. T3 minus T2, find out.
Minus 1 by 18.
Minus 1 by 18.
18.
Okay. T4 minus T3.
Minus 1 by 36.
Minus 1 by 36. Now tell me, are they, so this is the common difference you are finding, right?
Yes, sir.
Are the common difference same?
No, sir.
Then why you said this is in AP? So common difference is not same. D1 is not equal to D2, not equal to D3. Not AP. Whatever it is not AP. This is not in arithmetic progression, so we cannot use the same set of equations to solve this. Understood? Okay, first you have to subtract the term, unless it is mentioned in the problem that these series of numbers are in AP. Numbers can be in terms of variables also, right? So if it is written that A, B, C, D are in AP, that means D minus C is equal to C minus B is equal to B minus A. As simple as that, which is equal to, of course, the common difference. Here D is just a variable, not the common difference. Okay, this will be equal to common difference. Yes, got it? Hari, I'm talking to you. Hari, you got it or not?
Yes, sir. Got it.
Okay. Oh, all right. See, there are proofs, but again, I'm not going to go into proofs. If you want, please tell me. I'll just do the proof as well of the sequence and series. But while solving questions, I suppose we'll be doing proofs anyway. Okay. Now, since AP, find, let's write, find the AP, or find the arithmetic progression if first term, let's say T1 is 0, common difference usually denoted by D, or see, this is also written as A. First term is also written as A sometimes. So I'm writing T1 is 0 and common difference D, or let me write common difference D is your 5. Okay. Last term is 45. Find the series. It's very easy, right? Easy for you guys? Tell me.
Yes, sir. 0, 5, 10, 15, 20, 25. Out of 40.
So first term is 0, it's already given. Okay, and the common difference is 5. That means in to find the second, so this is T1. I know this is easy, but let me write it. So T1 or T2 will always be equal to T1 plus D, common difference. So T1 is 0 plus D is how much? 5. So the second term will be 5. T3 will be T2 plus D. Now T2 is 5 plus 5. So this will be 10. T3, oh sorry, T3 we already got. T4, in a similar manner you can get. So how many terms are there total? 15, 20, 25,
Sir, 8 terms. Sir.
30, 35, 40, and the last one is 45. How many terms are there? T4, T5. So this is T6, T7, T8, T9, and T10. How many terms are there total? 10. 10 or 9? Is it 10 or is it 9? I want to know that.
It's 10 only, sir.
10 only. 10 only, is it? Okay. Anybody with 9 terms? First term is 0, right? See
Sir, 10,
here,
sir.
yeah, it doesn't matter first term is 0 or not, right? We are not writing the, it's given that the first term is 0. Okay, that means 0 is a number here. So there are total of 10 terms. Okay, that means, and number of terms we write as n. Okay, so n is equal to 10. Okay, we'll find the relation between first term, the last term, and the common difference, everything. So write a theorem, or yeah, let's write it a theorem. Okay, if A and D, write down, if A is the first term, D is the common difference. Okay, so the AP, how you can form AP? AP will always be given by AP. Let's write AP is written as AN or TN. Both notations are used. I don't know in NCERT which notation is used in NCERT. Anyone you can use, it's fine. Okay, let's say TN is equal to A, the first term, plus n minus 1 times the common difference. And n is always a natural number. Okay, please mind this. N is always a natural number. Write down this. So you can write Tn or An. This also you can say the last term. Last term also you find like this only, right? Isn't it? Okay, we'll talk about last term a little bit later, right? So there is a proof that I was talking about. Let's do it. Let's do the proof as well. So this is the theorem. See, first term we have already mentioned that it is A. Common difference is D. So second term will be A plus D. Third term will be A plus 2D, right? Fourth term will be A plus 3D, and so on, isn't it? Yes or no? So this is your T1. This is T2. This is T3. And this is T4, and so on, right? Now from this, can we write, so what will be Tn? Corollary, what we can write, Tn is equal to A is common in all, see, plus n minus 1 times of D, right? Can we write this or not? Because see, in second term, the value of n is what? 1. In third term, the value of n is 2. In fourth term, the value of n is 3. Okay, so in nth term, the value of n will be n minus 1, right? Anybody is having any doubt or anything you want to say, ask, anything at all? So is that okay? N belongs to natural number. I know you guys have studied all this, but I need to start from the beginning, right? So I'm starting from the beginning. So let's solve a question based on this. Find the 20th, find 20th and nth term of the sequence 4, 9, 14, 19, and so on. So this is the sequence given to you. Find out the 20th term and 9th term. Sorry, nth term, sorry. Do I have the NCE all?
The 20th term is 99 and nth term is 5 n minus 1.
Okay, okay, let others find. 20th term is, yeah, okay. Anyone else? Anyone having doubt in this problem? You need any help? Okay, then solve it yourself. Got it? Shikruti, you got the answer?
Yes, sir.
Okay, so everyone got the answer, hopefully. Now, see here, the first term A is 4. What is the common difference? See, it is said that these are in AP, right? Is it in AP or not? First, tell me that. It's not been mentioned in the problem. But if you find the difference, what you will get? 5. 5. 5. That means these are in AP. So common difference is 5. Common difference is 5. Fine. You have got the first term. Now you know you can write the nth term. Tn is equal to, we know, a plus n minus 1d, right? Now you have to find Tn. So a is how much? 4 plus n we don't know, because n we don't need to substitute n, and d value is 5, right? Multiplied by 5. So this will be equal to 5 plus 5n minus 5. This will be Tn will be equal to 5n minus 1. Okay, so this is nth term. So this is your nth term. Now how you will find 20th term? You just substitute n is equal to 10 to 20. N is equal to 20. Fine. That's what we are going to do, no? So T20 will be equal to 5 into 20 minus 1. That will be equal to 99. Okay. Any doubt? Anyone having any doubt at all? No, sir. Yeah, anybody is having doubts, so you can speak. It's fine. Or I'll just move ahead. Okay. Now, okay, so suppose you are given the term, we have talked about arithmetic progression, but in general, let's say any series is defined, let's say Tn, okay, any series this is, let's say, no, let's not write Tn, let's write Xn. Xn is defined as n into n plus 5, okay? Let's say n is defined like this. So you can find the first 5 terms. So first x1 will be what? You just substitute n is equal to 1, right? So x1 will be 1 into 1 plus 5. How much is this? 6. Now, if you substitute n is equal to 2, you will get x2. That means 2 into 2 plus 5. It doesn't matter what order it is following. So 14, right? N is equal to 3. So x3, the third term you are getting 3 into 3 plus 5. 8 into 3 is how much? 4. So x4 you will get. x4 will be 4 into 4 plus 5. Is 6, right? So you are getting a series of numbers, right? And this is the order, and the order is defined by this. Order is defined by this equation, and these are the series of numbers. So this is also a sequence and in a series. Okay, it can be anything. It doesn't see right now in this chapter we are mostly exploring the arithmetic progression and the geometric progression. Only these two types of series we are exploring. Okay, but series can be of any form. All right. So in exercise 9.1, we are talking, just turn on to page number 180, exercise 9.1. See here, the same question, right? The first 5 terms of each of the sequence in exercise 1 to 6, this like question number 4, it says an is defined as 2n minus 3 upon 6. So first 5 terms, how you will find? The first term, how you will find? A1, you substitute n is equal to 1, you will find A1, that is equal to 2 into 1 minus 3 upon 6. How much is this? Tell me someone, how much is
Minus
this?
1 by
Minus 1 by 6, right? So similarly, you substitute n is equal to 2, you will get A2. N is equal to, let's say 5, so you'll get A5. So you just substitute 2 into 5 minus 3 upon 6. So minus, 7 upon 6 you are getting. Okay, so similarly you can find this as well and the other 2 terms, right? Yes.
yes, sir.
Find the see it's okay. Do exercise 9.1, question number 9. Solve it. It's really simple. See, an is given to you. An is equal to minus 1 to the power of n minus 1 into n cube. Okay, you need to find n a9, the 9th term you need to find. How you will find? Substitute n is equal to 9. You just substitute n is equal to 9. What you will get?
$720.
Okay, so a9 will be equal to minus 1 to the power of 9 minus 1 into 9 cube. Okay, so minus 1 to the power of 8 multiplied by 9 cube is how much?
729.
729.
9.
Okay, now minus 1 to the power even, right? So it will be positive, right? So a9 will be equal to 729. That's it. That's what you need to do in the whole exercise. So hopefully exercise, okay, the last question is Fibonacci series. See? Okay, it is given Fibonacci series. Question number 14. Let's do that. Solve someone question number 14. Please do it. See, if anybody is having doubt, you can ask me at any point. Question number 14. See, for Fibonacci series, the first term and the second term has the same value. A1 is equal to A2, which is equal to 1. Okay, and the next term, other terms, an can be found by an minus 1 plus an minus 2, right? If n must be greater than 2. That means the sum of the previous 2 terms. Okay, sum of previous 2 terms. That is your Fibonacci series. Now, what you need to find out? You need to find, in this problem, you need to find an plus 1 upon an. Okay, for n is equal to 1. If n is equal to 1, what do you need to find? A1 plus 1 upon A1. So A1 plus 1 is A2 upon A1. So A2 and A1 have same value, that is 1, 1. So this will be equal to 1. Second is if n is equal to 2, right? So if n is equal to 2, so you need to find A2 plus 1 upon A2. A2 plus 1, that means A3 upon A2 you need to find. So A3 third term is what? 2 upon 1, that is 2. Okay, the third one, n is equal to 3. So A4 upon A3 you need to find out. A4 is how much? Fibonacci series, the fourth term is how much? First you have to write down the series here. Using this expression, you need to write down the series. So it is 1, 1, 2, and the summation of these two, that will be equal to 3. Summation of these 5, summation of this 8, summation of this 13, summation of previous two terms. Okay, so this will be A3 will be, if n is equal to A4 is how much? 1, 2, 3, 4. A4 is 3 and A3 is how much? 2. So that means 3 by 2. If n is equal to 4, that means A5 by A4 you need to find out. That means 5 by 3. That's what the answer is. Okay, got it? Anyone got it or not? This is your Fibonacci series. See, the first term and the second term is 1, and the other terms are the summation of the previous two terms. Like A3, if you put A3 here, what you will get? A2 plus A1, right? So A3 is that. Got it or not? Or do I need to explain Fibonacci series? Anyone, please tell me. All good? See, if you won't say, I will go ahead. That's it. Naveen. Okay, who's in chat? Shreya, you got it?
Yes, sir.
Abhinav was there, right? Hari.
Yes, sir.
Okay. Anybody's having doubt, you can ask me, okay? All right. So what is the 13th term of Fibonacci series? Find the 13th term of Fibonacci series. See, Fibonacci series is defined by an is equal to an minus 1 plus an minus 2. A1 is equal to A2 is equal to 1. That's it. So find A13. That means you need to write the complete series. 1, 1, 2, 3, 5, 8, 13, 21, 34. Next is how much? 55, right? Next is how much? 89. Next, so how much is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11th, till 11th I've written. Write the 12th and 13th. Just add these two. How much you will get? $144. Now add 89 and 144. How much you will get?
2, 3,
How much? 2,
33.
33. So this is your 13th term. Got it? That means you are just adding up. You add up these two, the previous two terms. Right? That's what we are doing now. That's what we have been doing. So write down the next term. All right. So the next term will be how much? 377, right? Next will be how much? 610. So like that, you can keep on writing the Fibonacci series. All right. So exercise 9.1, I suppose you all will be able to solve it. There is nothing much in that. Now coming back to arithmetic progression. So show that, find, this is again AP, question number 2 in AP. Show that the sequence, I'll give you a sequence, log A, log A square upon B, log A cube upon B square are in AP. Show that these are in AP. So this is your first term, this is your second term, and this is your third term. So if this need to be in AP, what was the requirement? If this is in AP, what is the requirement? Huh? What is the condition for a sequence to be in AP?
Common difference.
So say that your common difference, right? That means T3 minus T2 should be equal to T2 minus T1. That is the common difference, right? That you need to find out. Do it. If the common difference is same, that means this is in AP. Otherwise, this is not in AP. Find out. Shri Kruti, Hari, Raghav, Shreya, you will calculate T3 minus T2. And others, you will calculate Nidhi, and who else is there? Hari, Haran, right? Abhinav, you will calculate T2 minus T1. Tell me fast.
So T3 minus T2 is log A by B.
Log A by B. Okay. Okay. T2 minus T1, how much? You know how logarithm properties of logarithm, right? Huh? Guys?
So no, sir.
No, sir. Then who you are expecting me these things? When I was teaching, everyone said no, but they don't want to know this. What is the third term? A cube upon B square minus log A square upon B. Oh, how can you just say no, sir? Haven't you studied that in chemistry and in physics? First
Not
chapter,
yet done, sir.
dude. It is in the first chapter, mathematical tools. Don't tell me that these things.
No, so they haven't.
In physics, this
Okay.
is in first chapter. Okay. Don't say they because I think Raghav is taking that class, right? You can ask him. Don't logarithm is there. Yeah. Logarithm is there. Exponential is there. Trigonometric function is there. Everything is there in the first mathematical tools. Just go and turn the pages once. Log A cube minus log B square. See, log A upon B can be written as log A minus log B. This is the property. Log A multiplied by B is equal to log A plus log B. Okay. So that's the property that we are going to use. Again, log A to the power of B can be written as B log A. Okay. So these are the three properties of logarithm that we are going to use it here. So this is the first term that we have written. The second term, we can write log. Okay, let's put this in bracket. Log A square minus log B. Okay, fine.
Yes, sir.
properties of logarithmic function. Don't say these things that you haven't studied. Don't put these type of excuses. So this will be 3 times of log A minus 2 times of log B. Okay. Minus 2 times of log A plus log B. Fine. So what this will become? Log this and this, if you subtract, you will get log A. And from here, you will get log B. So log A minus log B can be written as log A upon B. Okay. So this is your common difference, T3 minus T2. Of course, if you use the same property and you will find T2 minus T2. Find out T2 minus T1 yourself. Write down these properties. I don't know even you guys are writing even or not. These are the 3 properties that we are using it here. Okay. Write down these 3 properties and find out T2 minus T1. Nidhi, what happened to you? T2 minus T1. You are able to see my screen, right?
Yes, sir.
Okay, I think. Got it? T2 minus T1, how you will find out? So second term is what? Log A square upon B and minus first term is log A, right? So this you can write log A square minus log B minus log A. So this will be 2 log A minus log B minus log A. So this and this together you can write log A. 2 minus 1 will be 1. So log A minus log B, which again you can write log A upon B. So the common difference is log A upon B, which is common in both, which is also equal to T3 minus T2. Therefore, it's an AP. Okay. Solve this problem. Which term of the series and I'll give you the series 37 plus 32 plus 27 plus 22 and so on is minus 103. What is the question here? See, here you need to find which term. You need to find the value of n. Okay, find n for which you are given the last term and you are given the series. Okay, so find the value of n. How can you find this?
Also 29.
29. So okay, we know Tn is equal to A plus n minus 1d, right? Tn is already given here, right? Tn is given 103. Tn is minus 103. So it's given A value is given how much? 37. And common difference is how much? Anyone, common difference is how much?
The -5.
-5. So you just substitute these values. -103 is equal to A37 plus n we need to find out into -5. Right? Yes? Isn't it?
Yes, sir.
Okay. So can we write this as okay, -103 minus 37 is equal to -5n minus 5. Can we write like this? Yeah, we can write like this. Just think about for a minute. So this is how much? -140 is equal to -5n minus 5. Okay. See here, I just multiplied 5 inside and I took minus in front. Here, I have taken this to this side. That's what I have done. So minus will get cancelled out. So this again, if you take 5 this side, what it will become? 140 plus 5 is equal to 5n, right? So this is equal to how much? 140 plus 145. So n will be equal to 145 upon 5. How much is that? Huh?
29, sir.
29. So the 29th term is or what you can write, T29 is equal to -103. Okay, got it? See, anybody is having doubt that why Tn is equal to -103? This is the last term. See, this is the series that we are writing, right? This equation is for the series and the series ends here, right? So whatever the value of n means, like we got the value of n as 29. So that will be the last value of n for the series, last number of term. So that's why it is the last term as well. Okay, like if you put Tn is equal to 27, right? If you put Tn is equal to 27, you will get n is equal to 3. Okay, if you put Tn is equal to 22, you will get n is equal to 4. Okay, the fourth term. You can substitute here. Let's write down 37 here. If you write the first term 37 here, 37. So this will be equal to 37 plus n minus 1 into common difference -5. What you will get? You will get n is equal to 1. The first term. Got it? So I want you to solve all the problems of AP from exercise. What 9.2? No, 9.2. Not sum, just the arithmetic series. AP. Okay, so from question number 1, 2, 3, 4, 5. Okay, till question number 5. 1, 2, 5. You can solve. Sum is also really easy. We can cover sum tomorrow, and we will also see geometric, arithmetic mean and geometric progression tomorrow. Okay. Thank you so much. Bye.
Thank you, sir.
See, if anybody is having doubt, you can ask. Yes. Yes. Tell me. It's fine. Who is that? Hari? Was that you? Okay. See, if nobody is having doubt, you can ask me tomorrow as well. Just try to solve the problem. Okay. Solve the problems that I asked you, and we can finish it fast. Bye.
Yes, sir.
Thank you.